it's quite hard to get my head around because, you know, this wasn't included in my electrical engineering degree.
No, it isn't.
Because it's merging into physics.
It sure does.
So, if we plot the magnetic field, you said that it's more like a magnetic wave between the rollers.
Yeah, there's a bit of a waveform on it, which is why I built a device to scan that waveform. You have a Gauss meter, and then we rotate the ring, and we're able to scan the waveform. Right. We put it into a storage oscilloscope, and we can actually trace it out, plot it out. Right. So that has been confirmed, by the way, through my research.
Right.
Bear in mind that halfway round the plate height, it's at 0 point. And then it gradually increases the magnetic strength as you go to the top. You reach the peak of your magnetic field. Then you start decreasing to 0 point. Then you go the opposite field, slowly increasing to peak, decreasing back to 0. And that's how it goes all the way around the system.
Right.
The roller sits at the base of the curve. Yeah. So every roll you put on seeks a base in which to sit on.
So what keeps the roller off the ground when it's whizzing round?
It keeps it off through eddy currents, the interaction between the copper layer on the stator
it's
ring.
Floating. It's floating,
right.
Effectively.
And also there's another copper layer on the rollers as well.
Right.
The magnetic interaction and the fluctuations create eddy currents that allows it what's called a magnetic bearing. And when you have something like that, you know, a magnetic bearing means you have no wear. Right. And that's great with any device.
So are magnetic bearings used in industry at all? Hardly. Right, okay. It's a bit like magnetic levitation.
It'd be nice if you had a motor with a magnetic bearing. That means you wouldn't need lubricants and you wouldn't have any wear. So
they're called rollers, but they don't actually spin round.
Yes, they sure do.
Oh, they do spin round.
Yes.
Right.
Without touching anything.
Right. So they're what, a few mil gap between the roller and the outer layer of the inner ring? Is it? What's the gap?
It depends on the field strength, but in the SEG, John, would you describe it as a 1 mil or 2 mil gap?
About 2 mil. Of course, maybe other metals will lift it a bit more. But in any case, 2 mil or more means it's floating. There's no friction on the plate.
I want to add that I have built a demonstration unit to prove that principle. Yeah. It's a fact.
So we'll come on to the demonstration unit. You actually have outer coils on the outside which actually puts energy into the system.
No, what I have in the demonstration unit is the large ring. Instead of moving the roller, I move the large ring to isolate the effect. And then I have a roller on it with an asymmetrical magnetic field, and it will float and it will rotate. Right. I can show you a clip on that.
So it's been the roller's been kind of almost held there by eddy current. It's fascinating to watch it whizzing around. It doesn't fly off. Yeah.
Right. There are two forces at work: the general attraction from the large magnetic field, and the opposing fields of the eddy currents. Right. Between those two, it finds an equilibrium, which allows it to kind of float and spin at the same time.
So it's very similar to a moon going around the Earth, then.
Yeah.
Similar, but not the same, because that's gravitation. And we're talking about
because it is orbiting around a larger body. Yes.
Right.
Well, to make it easy, if we say that the plate was the size of the planet Earth, the roller was the size of the moon. The distance at which that roller would go round is the same distance from the moon to Earth. The same laws are applying. So because the plate itself is brought down small, the moon is brought small, we have a smaller orbit. But whatever happens, the same rules between Earth and the moon is applying to this plate and this roller set. Right. In other words, the plate is a heavy lump of gravity. The roller is a smaller lump of gravity. And they are reacting the same as the planet and the moon are reacting. There's no difference.
All right. Now we come on to the superconductive element of this. The whole thing cools down when it starts running. Yeah. I mean, have you measured any changes in temperature with the model that you've
I'm
done?
not at that stage yet.
Not at that stage.
That's what we're looking for, more
right.
Funding and resources.
All right. And I mean, we know that from normal physics that conductivity requires very low temperature. And so does it sort of go into a different mode once you reach that superconductive state then?
Keep in mind that the more energy you take out of the machine, the colder it gets. Why? Because temperature is being converted into electrical power.
Yeah.
If you don't have a lot of vibrations and chaos, if chaos is being reduced, consequently temperature is being reduced because it's being converted into coherent currents.
Right.
That's why that's why it gets so cold. The problem with John's original generators is that they just went all out. And the temperature dropped quickly.
So as it gets more cold, does that make the efficiency of the machine higher then? Is that?
Oh yeah, the cooler it gets, the more efficient it is.
Or the more effective, you might say.
Right. So we have two operating modes, one above superconductivity, one below.
Right.
And above the superconductivity, we can utilize it as a generator. Right. Below, it becomes a transportation, you might say. In John's case, it was an out-of-control situation where it experienced levitation, or John calls it inverse gravity, where superconductivity has an effect in his machine with gravity itself.
We know that people like Eugene Podkletnov, are you aware of his work? He has spun superconducting disks in magnetic fields and noticed that their weight reduces by a certain percent.
Right, they notice an anomaly. Yes.
Yeah, but this craft machine basically completely overcomes gravity. Can you explain that? How is it doing that? I mean, I know it's quite difficult to explain, but can you try?
John, how would you explain the inverse gravity effect?
Well, all I can say here from my past experience is that when the craft is forced up, now the craft is being forced away from the Earth, not using energy to push it up. What has happened then, you reach a speed level in which the whole ship is at superconductor state. Here, gravity, half of the gravity seems to have gone outside, made a bow wave around the vehicle.
Right.
And the other half seems on all tests to remain in there, in the ship itself. Right. So travelling on board a ship will be no different than half the force acting on you now. You can't feel that 1G, so you won't feel the half G either.
Yeah.
What is happening is that as the power builds up, the ship is more easier to control and the faster it can go. But whether you are on Earth to build this power up or in space, in space it's in better because I got pushed out the spare way. But the half G still remains. So the half G means that the extra G is now creating that half G effects on your body.
Right.
So you're always kept at half G.
Right.
So you can go at any speed, you can flip over, no problem.
Right. The interview that I did with this guy called John Duffield, he explains the similarities between magnetic field and gravitational field. He believes that they're both effects on space itself. So electromagnetism or electromagnetic field is effectively space which has been twisted in two planes. So if you twist it that way and that way, it's a piece of twisted space. And the gravitational field is a piece of stressed space. So if you imagine a block and you put stress into it, it's more difficult for light to pass through it. So the two are related in that they are effects of space. And so I'm of the mind that electromagnetism can be used to create effects within gravity. It's just that in our conventional electric motors and generators, the fields aren't big enough to affect the gravitational field. Is that
it's not so much big enough, it's doing it just right.
Right. Would you describe it as resonance?
Right. From what I've learned, it appears that the matter has various facets. You have a motor. Well, in a different mode, it could be a generator. You have gravity. You can make it reversed.
Yeah.
John calls it inverse gravity. So we believe there are facets to all these forces. It's just a way of, you got to find a way to engage it and modify it.
Of course, something people don't realize, light and magnetism is electrons. We're looking at electrons in action at different angles, but they are all the same. They're just the same. The other thing is light is shown as 7 different bands, which gives us different colors due to the frequency of the band. Magnetic has always been shown as 1 band, but because light, electrons, magnetism are all one, the same thing.
Yeah.
Therefore, I said back in 1946, then the magnetic field is identical the same, because they are related to each other.
Yeah.
So there must be in bands. What we're doing is our magnetic system, which is I call conventional magnetism, uses white light. All the bands are all in one. What we've done is separated one band. It could be the blue band, the blue light, and its band of magnetic field. We got that band. When you separate the bands, they're much more powerful than when they're all together. So I say that our magnetic field really is in the blue band region of frequencies. And again, we got another issue. Every material has its own frequency. What we're doing is we try to make a compromise between all these 4 frequencies into one sort of base frequency, so that we'll always go the same way. So when you put your rolls on the first plate, scientists always say the next lot will go in the opposite direction. They don't. They'll all go the same way. Same with it. You got another band. You could go, but let's put it this way: the voltage steps up. Every band you have, you put these extra rolls on, and the power is really going up. I find 3 plates are good enough for a house, and even for cars and lorries and buses. But when you come to flying, we don't put the extra plate on. What we do, we add 2 more elements to the system. That this bangs up the energy even greater. So it's a combination. You have to decide what materials you're going to use, and remember that all materials have different density, and we work into density. So we have to know the density of the material so we can decide how wide that band's going to be. Next problem is, will the thickness we pick for the wall be powerful enough to hold the magnetic field? Or will the field fall off? These are all sort of things we have to consider. So nobody can just go make one in the shed, amen. It's a very complicated thing. It looks simple watching it. What makes it very amazing to think that a weight is spinning there, not tied to any shell or form, and it's spinning racing around there, and it don't fly off. And as I say, one more said to me on the internet connection, boy, that roller is spinning around that plate. I said, how many volts are you using? 5. I said, burnt it another 2. I did. They come back. It's going crazy, because the speed is immense.
So just to come on to the model that was shown in the film, where you've got some LEDs and you put them into the field and it's generating an EMF. In that model, you actually are putting electricity into that system. That's not a working model, is it?
That's what we call the SEG mock-up. It's far short of a prototype because we don't have all the elements into it. It's magnetic and copper. What we're doing there is demonstrating some of the principles of the SEG, just by its own physical setup. Automatically, you see that the rollers space out by themselves. They also stay on track. These are confirmations of the concept. And this is the way I do my research. I try to isolate the principles of the SEG and then demonstrate it. And I have 4 demonstrators so far.
Good. And just to go into the material that's holding you back, that's holding you back, you're getting...
What's holding us back is the kind of funding that will support the kind of infrastructure necessary to build an SEG. Remember, when John first started out, he had everything in place. Personnel, facilities,
right.
engineers, and all that.
All right, so
that's what I'm trying to recreate for John.
And you need some of this is it rare earth element. Is that the main thing? Is that the main cost that you're?
No, it isn't. It's the facilities,
right.
the manpower, the research, the companies, the power sources, and all that. There's a lot. There's an infrastructure that's necessary to build an SEG. You just can't make it. We have to deal with reality.
Right. And you're seeking
Oh,
interested parties. So
we're seeking investors. Yeah.
Yes. So if there are any,
if we're going to start from scratch, we're going to need $3 million at least.
Right.
And that's to prove the Searl effect.
Right.
And then from there we go on to manufacturing.
All right. So if there are any people watching who would like to get involved in investing their money into this project, then
we do have parties interested, but we have to sort them out.
Right.
You know, sometimes they're not what you think they are. We have
right.
to
yeah.
sort them out, as I said.
So.